Hello, friends, architects, engineers, and consultant engineers, and other students. Once again into VK Jain Sir ki MEP classes. In this module, I will be discussing and teaching illumination calculations. Friends, before we proceed for how to make the calculations, uh, some terms are necessary to be learned by you. Utilization factor or coefficient of utilization, it may be defined as the ratio of total lumens received on the working plane to the total lumens emitted by the light source. That is, utilization factor is equal to lumens received on the working plane divided by lumens emitted by the lamp. The factors affecting utilization factor are type of light, light fitting, color surface of wall and ceiling, mounting height of the lamp, area to be limited. Its value lies from 0.4 to 0.6 for direct lighting. Friends, the next factor is maintenance factor or depreciation factor. It may be defined as the ratio of illumination under the normal working condition to the illumination when everything is clean or new. That is, differentiation factor is equal to illumination under normal working conditions divided by illumination when everything is clean. The maintenance factor is based on how often the light are cleaned and replaced. It takes into account such factor as decreased efficiency with age, accumulation of dust within the fitting itself, and the depreciation of reflectance as wall as ceiling age. For convenience, it is usually given as three options. Good 0.8, medium is 0.65, and poor is 5.6. Friends, third factor is coefficient of utilization, normally written as COU. This coefficient of utilization indicates the percentage of light emitted by the lamp which reaches the working plane. This factor takes into consideration reflecting efficiency, shape, and mounting height of the luminaries, shape and dimensions of the room to the luminaire, and reflecting efficiency of the ceiling and walls of the room. While calculating coefficient of utilization, we first calculate room index. Room index provides the method of classifying and grouping the rooms in case of interior lighting, depending upon the layouts and dimensions of the rooms. Room index is used for determining the coefficient of utilization defined under point 5 below. Room indices can be obtained from the following. For direct, semi-direct, and general diffuse light illumination, it is Now we come to calculating of illumination level. Friends, illumination level denoted by E is defined as total lighting flux phi in lumens in an unit area A. Say A in square meter is equal to E equal to phi upon A lux, where E is illumination in lux, also called illuminance, and phi flux in lumens of lamp. Friends, now E equal to phi into capital N, then coefficient of utilization and coefficient of maintenance divided by area, where E is illumination in lux, also called illuminance. Phi is equal to flux in lumen of lamp and number of total lamps, and U utilization factor, and Nm maintenance factor. A is area in square meter. From this formula, we can calculate the number of lamps. N is equal to number of lamps equal to E multiplied by A divided by small n small n phi coefficient of utilization and coefficient of maintenance. Flux per lamp is wattage and into efficiency. Lamp efficacy, total lumens of lamp divided by lamp wattage. Friends, in case of semi-indirect and indirect light distribution, the room index is calculated by this formula. Room index is equal to width of the room multiplied by the length of room divided by ceiling height above work plane multiplied by width of room plus length of room. Friends, in this slide we have shown recommended values of illuminances, that means illumination factor for some activities as given in National Building Code 2017. In this particular chart you will be able to see that three values have been recommended for, say, in all cases. In case of a small safe, three values: 300, that is the lowest possible; 500, that is the desired value; and 750 is the higher end value, and similar for all other. Friends, the similar chart as in previous slide, but for uh, places of public assembly, including public room, concert hall, auditorium, libraries. Friends, the same chart, but for hospital and commerce, education and general building areas. Friends, this shows illumination level in different part of residential complexes. I will read. Entrance hallway illumination level could be 100. Living room it should be 300. dining room 150, bedroom generally 300, dressing table, bed hacks 200, and so on. Friends, this is a typical calculation for calculating room index, which is L into B divided by L plus B multiplied by room of height. You can assume height if it is 3.65, room index is 5.48. Friends, this figure shows you coefficient of utilization for direct lighting system as was given in BZ classification being used previously. This table is for room index, floor, ceiling and wall 10%, 70% that is, and wall three different value 10, 30 and 50. And if we have already calculated room index in this column, this row from 0.6 to 5.0. So you can calculate if suppose your floor is 10%, ceiling is 50%, and suppose we take wall coefficient 30 and suppose the room index is 2. So we get 0.42 as coefficient utilization, and this is the fitting for which all this chart has been prepared. This is known as box type fitting, having single tube, and this is having double tube, and these are the two polar curves of this fitting, this particular box type fitting. Friends, same type of chart which I have shown in previous slide, but it is for industrial trough cover light fitting with three tubes. Friends, now we are discussing maintenance factors. This factor determine the light which will actually be available after luminaire has been in service for some time. Reduction of light is caused by following three elements. Reduction in light output of fluorescent tube. During the first 100 hours, the fall in light out, output is more rapid. Light emitted after this may be taken fairly constant till 18,000 hours of service. The fall in light output thereafter becomes more steep. Second factor, loss of light because of reduction in reflecting efficiency of walls and ceiling of the room. This is caused by accumulation of dust and dirt. Third, absorption of light due to dust collection on the lamp, the reflecting and or diffusing surface of luminaire because of exposure to atmosphere. Friends, in the last slide, We have seen that loss of light is uncontrollable. The, those listed under item V and C can be minimized by proper maintenance. Values of the maintenance factor to be used under different circumstances are good and clear condition 0.7 to 0.8, average condition 0.6 to 0.7, poor and dirty conditions 0.5 to 0.6. For general lighting of an interior, the number of fixtures required is calculated by use of following formula. The number of fixtures is equal to area in square meter multiplied by desired level of illumination in lux and divided by maintenance factor multiplied by coefficient of utilization multiplied by number of lamps per fixture multiplied by lumen per lamp multiplied by absorption factor. Friends, now we start calculating. In example 1, calculate the number of fitting required and how they shall be mounted based on following data. An office area has length say 20 meter by width 10 meter and height having 3.65 below false ceiling. The ceiling to desk height is 3.65 minus 0.75, that is 2.85 meters. The area to be illuminated to a general level of 300 lux using twin lamp 28 watt T5 fluorescent luminary with of space height ratio SHR equal to 1.25. Each lamp has an initial output efficacy multiplied by 100 lumen per watt. We have assumed room size of 20 by 10. Minimum desired illumination level from National Building Code 2016 equal to 300 lux. We will use twin box type fitting of 28 watt T5 having efficacy of 100 lumen per watt. Room to ceiling height we have assumed as 3.65. Utilization factor as calculated from utilization chart is equal to 0.6. Maintenance factor assuming average room condition in an office equal to 0.8. The formula for calculation is lux level equal to number of lamps and small multiplied by flux available from each lamp in lumens multiplied by utilization factor multiplied by maintenance factor. Room area is equal to L into B equal to N multiplied by 28 multiplied by 100 multiplied by 0.6, 0.8 and divided by 30 into 10. From this we calculate the number of fittings which is equal to 300 multiplied by 20 multiplied by 10 divided by 28 multiplied by 100 multiplied by 2 multiplied by 0.6 and multiplied by 0.8. This is utilization factor, this is maintenance factor, this is the wattage of lamp and this is the efficacy. So we get 22. We'll say 20 numbers 28 watt T5 lamp. Friends, this is the drawing in which we have utilized a this is the first of mounting arrangement of ceiling. In this we utilize the formula if the fitting to fitting vertical distance is 2.5 meter, we have taken here 1.25, so that this particular fitting has a area like this, which is 2.5 meter vertical and horizontal. We'll see the room is 10 meter by 20 meter, and we have assumed vertical distance to be 2.5, and we have assumed horizontal distance of 4 meter. This is one of the mounting arrangement. We'll see other mounting arrangement also, because when we insert ceiling fan, we this insert the ceiling fan can come here, and come here, 4 rows. Well, it depends upon how many ceiling fans are there. So we'll see the second mounting arrangement. Friends, I forgot to mention that such plans in AutoCAD or otherwise are known as reflected ceiling plan. Now this is the reflected ceiling plan for illumination scheme for a room of 20 meter by 10 meter under consideration, provided with twin 36 watt LED luminaire and 1200 ceiling fans. So as calculated, we require 12 number ceiling fans. So under this schematic, you can see that here also we have utilized the same formula, half x, half y vertically, y, y, y and half y. Similarly, horizontally, x, half x, 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 x and half x. So this is the one type of scheme. I have given the name scheme alternative 1. Friends, this is a scheme number alternative 2, which I have selected for a particular building. Now here we have utilized the same formula x and half x, 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 x. This is half x. Similarly, this is y, 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 half y, half y. The only difference between this and previous is that this is taken as good alternative because we have increased the number of ceiling fan as compared to required number of ceiling fan, but this will provide better ventilation and schematic distribution also very good for ceiling fan, false ceiling. Friends, now I am discussing Alternative scheme 3 of reflected ceiling plan. In this scheme, I've taken half x, full x, full x, full x, full x, and half x. Similarly, y, half y, full y, full y, full y. This schematic is preferable from the angle of number of ceiling fan, which is 20. Friends, this slide provides methods of calculating illumination. Another alternative, the problem of lighting designer at the locus functional level is to determine how many light and where to place them to get the correct level of illumination for a given activity. These calculations can be divided in two types. One is point illumination method, second is total flux method or lumen method. If we want to determine the illumination at a small specific location in the room from a point view source, then we have to get polar plot of luminaire and then we have to work out the illumination or illumination on surface for a given lamp. This is called the point illumination method. This method is generally used for accent lighting. Second method is the total flux or lumen method. We want to estimate the illumination pattern from a set of diffuse lighting sources over a broad area in the room. This is more complicated exercise. We will be using the total flux method or lumen method to get rough and reasonable estimate of the lamp's luminaries needed. This method is used in areas where a uniform lighting intensity of the work area. This method is used for rectangular room with gridded luminaire pattern. Friends, this I have already read. Friends, we are discussing now home lighting design. Good lighting in the home contributes immensely to our well-being and our ability to complete the many varied tasks that are necessary in our home lives, all of which call for different lighting needs. Consider, for example, when watching television, you need only low light. Second, children completing homework need a high level of lighting. Third, preparing food in the kitchen requires a bright light. Fourth, eating meals calls for a warm, comfortable light. Next, the lighting should be energy efficient. And last, the lighting should also complement our interiors. These few situations clearly illustrate Dear friends, now we'll see how to design lighting system of master bedroom. Many books are read in bed which requires a high lighting level, but otherwise one would usually prefer gentle lighting at the end of the long day. The bedroom is also used as a dressing room and for applying makeup which require excellent color rendering. If you prefer fluorescent lighting, make sure you use a Philips true light lamp which gives good color rendering over 0.9. CFL wall light make an inviting and cozy atmosphere and save energy bills. CFL lamp also give good color rendition and should be installed close to the dressing mirror. A table lamp is convenient for the bedside table. If you read much in bed, we recommend you use a directional light with compact fluorescent to avoid stressing your eyes. The fitting should have an adjustable arm so that it can be positioned correctly to avoid glare. Mirolta is however tailor-made for dressing table. Friends, children's bedroom. Children bedroom should be lit with security and safety in mind. For a headside light, choose a fitting which uses a cool burning compact fluorescent lamp such as PLS or PLEC in case it gets covered by clothing, bedsheets or curtain. These are both safe and inexpensive to operate over extended period. They will allow you to safely leave the room until the child falls to sleep when light may be or may not be switched off. Staging under poor lighting can lead to fatigue, headache, and sports sightness. Lighting is crucial for students and others who spend time over books. High level of good quality light will be significantly improving concentration and speed of reading. Compact fluorescent lamp or TL lamps are perfect for studying as they provide even distribution light without shadows. They don't emit much heat and last longer. A student can concentrate longer under a cool color light, compact fluorescent, than a warm colored light given by incandescent lamp. Use a desk or wall mounted luminary with adjustable arm and shade so that light can be directed exactly where needed. A good reflector inside this shade increases the intensity of light and distributes the light without glare. Friends, now we are discussing the dining area. Requirements are you need to see what you are eating but not be blinded in the process. This is good for followers of Jainism also. Apart from normal dinner, dining room is also used for entertaining guests, children birthday party, etc. if they are big enough. The dining table can also serve as a desk for school homework, annual tax return, a games table, and even for dressmaking or hobbies. You will need different lights for these activities, so versatility is essential. Now, lighting for dining. Use a centrally located luminary for general lighting with a good diffuser to spread the light evenly. The use of additional lighting such as CFL wall lights will help create atmosphere or dramatize your dining area. Now we are discussing the kitchen requirement. The kitchen is the place used by housewife or any other working lady even. Most of their time is spent in kitchen. For kitchen the requirements are most accidents happen in the kitchen and many may have been avoided if there was a sufficient or appropriate lighting. Typical tasks include preparation and cooking of food, reading recipes and instructions, all of which require excellent level of lighting. Good color rendition is also crucial in order to judge the freshness and quality of fruits and vegetables. Cooking generates steam and grease, and it is important that the luminary or luminaire should be easy to clean. An energy efficient light source should be used to save cost and electricity solution. A combination of general lighting to illuminate the whole area and task lighting for food preparation gives the best result. Friends, this particular table had been taken from ECSBC code, which is for all areas which are exceeding air conditioned area more than 1000 square meter or having a lighting power requirement of 100 kilowatt or 125 kVA. This provides the lighting power density for energy efficiency point of view, and you can see the dining and dining family. These area require dining cafeteria fast food 15.1 and dining family room 17.2.